Hey, good morning, everybody. So March is upon us. It's feeling good. It's sunny right now when I'm videotaping this. So we got March Madness going on, the NCAA tournament. We got spring break coming up. And all in the middle of this, we got one of our most important units in math of the year, a unit that is going to be essential for students moving into 8th grade next year, which we call pre-algebra in 8th grade, where we bring everything together. We got tables, we got graphs, and we got equations that I'm going to be putting up here in a moment. So this is some really important stuff, and really for us, again, just putting everything together that we have been working on all year that you're going to see in this problem that I'm going to show you that we worked on this past week. So let's get going. So here was our first problem that we worked on, and really a good example of everything that we're doing right now. So in this problem, it's talking about this lady named Ms. Jackson who's translating books to another language, and she charges a upfront fee, an initial fee they call it, of $325. So here's my initial fee of $325. So that's a one-time fee, plus an additional $25 per page. So the first thing that we did is we wanted to identify our variables. Okay, that's been something that we've been working on all year. What are the variables in this story? And we always have an independent variable and we have a dependent variable. And our independent variable is always our x because it's related to our x-axis on our graph that we're going to get to in a little bit. And our dependent variable is always our y, which is related to our y-axis on our graph, which again we're going to get to in a moment here. So in this case, we're looking at what are the quantities that are changing or varying. These are going to be our variables. So we start with, well, the number of pages that she translates. That's going to be varying. So that's going to be one of our variables, and we're going to call that our independent variable. So the number of pages. And the number of pages is going to be independent, as I said. And then our other variable is going to be our total fee. Okay, how much money is she going to charge for total? And in this case, our total depends on how many pages that she translates. So this is our dependent variable and this is our independent variable. So this is going to be our x, the number of pages right here, which you can see I've already labeled, and our dependent, our total amount of fees is going to be on our y. Okay, so now we got our variables. Now we got to look at, okay, what are the things that are not going to change? What are going to remain constant? So we look up here and we have, well, right here, this $25 per page. That's going to be constant. That's a constant rate. And that word constant has been something that we have been constantly talking about all year. Okay, no pun intended. And then the other item in part of our equation is this initial fee, this $325. This is also something that is not going to change. So that's another piece of our puzzle that is going to be in our equation. So now what we're going to do is we're going to put all of this together into one algebraic equation. So I'm going to erase this for some space here. So a big part of writing the equation is not only identifying the variables and the constants, but also just translating. So if we look at this situation, we know that she's going to be charging an initial fee of $325. So let's get that $325 on there. And then it says she's also going to charge, in addition or plus that initial fee, she's going to charge $25 per page. And this is going to give us our total, the total amount of money that she's going to charge. Now, initially when we wrote this equation, we wrote it like this, and students did not really recognize any similarities to things that we did in the past. Until I reminded them, well, remember, we can switch things around here. So what if I were to write the equation like this? So now the hope was that students would remember this equation that we had been writing in the past that looked like this: y equals k times x, where k represents my constant, okay, my constant of proportionality. And you'll notice that that k lines up with that 25 because that 25 is my constant rate, which we're going to change that in a moment here. We're going to call it something else. That's not even the book. I kind of pushed the students a little further, and we're preparing them for next year, and we're going to call it what it actually is. Okay, and then this is the guy that kind of confused them at the end. Well, here there is no plus anything. There's nothing there. Well, it reminded them whenever we were graphing these equations that look like this, y equals kx, the graphs, if I were to sketch one real quick, the graphs typically went through the origin. Okay, and we'll come back to this in a moment here and put all these pieces together and kind of draw some dots together. But this was our equation, okay? And they started to recognize that, okay, this does kind of resemble this piece right here. And again, we're going to come back to this last piece. So now we have our equation. Now we went to our table was the next piece. So now how am I going to fill this table out? Well, I'm going to use my equation as my machine to help me produce or fill in the table. So now if I come over here, so it says how much is she going to charge for one page? So if I put in 1 for P, 25 times P is 25 plus 325, that would give me 350. If I put in 2 for the number of pages, so how much is she going to charge for 2 pages? So put in 2 for P, 25 times 2 is 50, plus 325 is 375. And it was here where students started to recognize, oh, I recognize that this is going up by $25. Oh, why is it going up by $25? Well, because it says she's charging $25 per page. Now the piece that's missing here is, well, what about 0 pages? Okay, what if she doesn't translate any pages? Now this may not make sense in the real world context, but in our math world this does. So what we did is we're going to put 0 up here into our table. So what about 0 number pages? Well, if I put in 0 for P, 25 times 0 is 0. But I still have that 325. Remember, she's charging 325 right up front. So we could say, well, she's still going to charge 325, which in the real world, this sometimes happens, right? Where we pay an initial fee before we even get any service. Okay, for example, a plumber. We might pay an initial home visit fee where they come to our home. We're going to pay them something up front before they even do any of the work. Okay? So there is some real world context to this. So now I have my table, and of course I would fill in more of these, and I can fill in this next one here. And again, the purpose of the table is getting them to see how I can use the equation to help me fill in the table and to see the pieces and to connect some dots here. So the next piece then, we went to the graph. So now students had to move all this information to the graph. So now, if I'm looking at here, so I'm going to go by ones, and I'm going to skip every line, give me a little space. So 1 page, 2 pages, 3 pages, 4 pages. And then over here for the total fees, I notice, okay, I go 325, 350, 375. So there's some big numbers. But I also remember that this down here, well, that's the origin, that's 0. So I'm most starting at 0. So I taught them about how we can put a break in the graph, which allows me to jump from 0 to, I'm going to jump right to 325. But then I'm not going to keep on going by 325s. I'm going to then go only by 25. So 350, 375, and 400. Okay? And this again just allows me to fit all the information in so that we can see what's going on here. So now I'm going to graph 0, 325. So that guy right there. Now that guy I'm going to put in red because that guy's an important point. We're going to come back to him. And then we have 1, 350. So there's that guy. And then 2, 375. There's that guy. Okay, so now if I were to connect these dots, it would show me I have what we called all the way back in the first semester a linear relationship. And if you notice in this word linear, we have the word line. So it's producing this straight line. Okay, and this is again a relationship that students saw a lot in the first semester, and they recalled, okay, I remember what that linear relationship means. Okay, so now it's time to connect some dots between the equation, the graph, and the table. And this is what this unit is all about. So the first thing I'm going to connect is this piece that we left off here. Okay, this plus whatever. If you remember when I was first referring to this, I said when we looked at this in the first semester, we looked at this y equals kx. And whenever we graphed these equations that look like this, they always went through the origin. Well, that was because at the end of this, I could have put plus 0, but I didn't need to because it's 0. But this and this are related. But in this one, notice it says plus 325. I'm going to put this in red so we can draw some dots here. And notice, oh, the graph crosses the y-axis at 0, 325. And notice in the table, I can also see this here. Well, this point is what we call the y-intercept. So this is the point where the line crosses the y-axis. And we can see it right here in my equation. We can see it right here in my graph. And we can also see it in my table. So again, we're drawing some dots together between the table, the graph, and the equation, which again is what this unit is all about. But we're not done there. Okay? Also, we notice, this 25. I can see this COP, this constant. I can see it here, and I can also see it here. Remember, this kept on going up by 25. There is my constant rate. And again, in the very beginning of the year, we started looking at tables. Okay, we were solving problems with just tables. And again, so we're going all the way back to the stuff that we did first semester. But now, how do I see it in the graph? Okay, and this is where this new word called slope came in. So if I look at my graph, I can see that every time I went over one unit or one page on my x-axis, I went up 25 or $25. So every one unit, I went up $25. So there it is. I can see it in my graph as well. And so what I reminded students of is this letter K here, all the way back to the first semester, we define K as y over x. So y, my vertical climb, over my x, my horizontal climb. So if you notice, I went up 25. So I went up 25 for every one unit I went over. So my slope, which we used to refer to as the constant of proportionality, is 25 over 1, or just 25. So now I can see a connection between my equation, my graph, and my table. And now this week, what we're going to do is I'm just going to mix these all up. I'm going to give students a graph, and I'm going to ask them to produce a table and equation. I'm going to give them a table, and I'm going to ask for a graph and equation. Or I'm going to give them an equation and ask for a graph and a table. Because what I want students to do, again, is I want them to make the connection between those three and see how they can easily solve problems using one of these three models. Sometimes a graph is easier to answer a question. Sometimes a table is easier. And sometimes an equation is easier. But they now have experience using all three models. And that is our goal. So we're going to test out this week, Wednesday. Looking forward to another great week. Have a good week, everybody. See ya.